In this video, we're going to try to find the derivative of the inverse cotangent of x. Okay, before we start, we want to see what we mean by the cotangent. So here, this is a quick review. Okay, so assuming this is some axis here that's 1 unit far away from the x-axis. So here, if we let x be this angle, so in this case, this is the cotangent of x. Okay, as we see here, x is between 0 and pi. Okay, and we cover the whole line. So when we go to 0 from here, where we're gonna get infinity. When we go to pi from the left, we're gonna get minus infinity. Okay, these two values are extreme. Okay, we're gonna come back to this one and we're gonna see what we mean, but not in this video. So here we can see it graphically. As we keep the angle keeps getting smaller and smaller, we tend to go to plus infinity, and as the angle keeps getting closer and closer to pi, we get to minus infinity. So here, between 0 and pi over 2, the cotangent is positive, and between pi over 2 and pi, it's negative. Okay, there is other ways to represent this one, but this is the best way. So think of the cotangent as being here with your x as this x value here. So now we're gonna we in this case we can define a inverse function that goes from r unto 0 pi, okay, such that for every x it does associate a function that we call cotangent inverse, or arcotangent of x. Okay, so now if we let y be the inverse cotangent of x, this means that we can write x as cotangent of y. This is, in fact, we have an equivalent statement here. Okay, so with this case, we can because it's inverse, we can let so our y here is in 0 pi. Okay, y is defined between 0 and pi. Okay, and our aim now is to compute dy over dx. Okay, how can we do that? So we can start from here. So we have cotangent of y equals x. But before that, we need to have some results in our mind. We need to know that d over dx of cotangent of x is minus 1 over sine squared of x. To get this result, just write cotangent as cosine of x over sine of x and differentiate as you have two functions, f over g, and we will get this one. Okay, the other thing is that 1 over sine squared of x is equal to 1 plus cotangent squared of x. Okay, this is a second result that we need to prove this result. Here, to prove this one, we can write this one here on top as sine squared of x plus cosine squared of x, and when we divide, we get this result. We get 1 plus cosine squared over sine squared, which is the cotangent. Okay, so given this result, now let's differentiate this one here. So we're gonna do implicit differentiation. So here, let's differentiate star with respect to x. We get d over dx cotangent of y is d over dx of x is just 1. Here, using the chain rule, we're gonna have d over dy cotangent of y times dy over dx equals 1. So our aim is here. We wanna compute dy over dx, but we know this one here. So we have this one. So we assume that d over dy cotangent of y is different from 0, because we want to divide by that. So given this one, we have dy over dx is going to be 1 over d over dy cotangent of y. But here, we prove this one for x. So in this case, we're going to have minus sine squared of y. okay, because we have y here, we don't have the x. But this one, using this result here, this one will give us minus 1 over 1 plus cotangent squared of y, okay? But the cotangent of y is x, okay? So here we have minus 1 over 1 plus x squared. Therefore, dy over dx is this one here. So this proves that the derivative of the, let me write it one more time, d over dx of cotangent inverse of x is minus 1 over 1 plus x squared. Okay, we can use the chain rule and we can prove that d over dx of cotangent inverse of u of x, so it's going to give us minus u prime of x over 1 plus u squared of x, in case we have a function here instead of x. So the chain rule gives us this result. So this is one way of proving that the derivative of the inverse cotangent is minus 1 over 1 plus x squared. There are many other ways that we can do, but this is just a reminder of everything that we have seen. And we can see that this is very it's easy if you know what you are doing, and if you have these formulas that one can prove along the way. So we need to know this one, that the derivative of the cotangent using the definition is this one, and this one we can get it from unit circle, or we can just prove it. And what else? And that's it. And we need to be careful when we divide by some number. We want to make sure that's not equal to 0. And here we use the chain rule to get the result for the derivative of the cotangent inverse for any u of x, not just x. Okay, and I think that's it. If you have any questions, please comment or ask. Thank you.